on November 2nd.
Hello, welcome everybody. My name is Chris Holmes, and I'm from team FRC 1073. I'm a mentor with the team, and today I have two sessions today. This first session is going to be about how to develop our scouting app. So we developed a scouting app for the past couple of years. It's a web-based scouting app. It uses a Raspberry Pi, and it's web based. So there's a web server on the Raspberry Pi, and we developed an interface for it so that our users could scout matches. Scouting is going to be a little bit trickier this year, I know, but I think in general it's a really neat technology that you can anyone interested in software development or web design or anything like that can take advantage of. So the hope is a lot of teams might find this interesting. We developed it because everybody knows the challenges of scouting at an FRC event. You can't use Wi-Fi. You've got to have a lot of. We've done paper. We've tried other things, and the solution came up pretty good. And so we thought we would share it with people. I'm showing you our website. So everything that I'm going to discuss and refer to today is on our website, frc1073.org. And if you look up under the resources here menu, you'll see Scouting App, and that's the page we're looking at right now. So all the information is available. This session, I'm going to focus on the software side, as I mentioned. How do we develop interactive web pages to be able to collect user input, try and make an interface that's intuitive for users so that they're not busy struggling trying to figure out how to write down or store what they're watching. Try and make it easy, just a few buttons. Um, and So we'll go over how we develop that in this session. And then in the next session, we'll discuss how to actually put this together. We'll discuss the hardware, how we cabled it up. Um, I'll show you real quick here. This is the assemble the hardware here. So this is all the hardware it takes. We've got a converter that plugs into a robot battery. We've got a Raspberry Pi that then cables up into an 8-port switch, and then the 8-port switch has Ethernet cables that connect to 6 tablets. And the key is these tablets can support an Ethernet connection. And so now these tablets can run the web server, the web interface, view the web pages that are being served by the Raspberry Pi. This kind of a setup is nice because all your data gets collected in one central location, and that allows you to really get creative with your coding, and you can come up with some various interfaces, to process the data. I'll show you real quick. Here's our scouting app running on a Raspberry Pi at my house here. A copy of the Raspberry of the code. So you go to Scout to start scouting, and this page lists the events. So these were the events that we scouted at last year before everything changed. We got some week 0 events, event scouting, and we've also went to the New Hampshire Granite State Challenge. So a scouter would come into this page, click on the event, orient yourself with the field. So determine if you remember the picture I showed you of the tablets, some tablets are red, some are blue. So the scouter would pick red, which position are they scouting? And from here, they would begin to see the matches that were uploaded. And you can see we've got the quarterfinals and semifinals matches in here. And so they would determine which qualification event they're about to scout. And then up comes this interface. And I'm going to talk a little bit about the code that we wrote to create this interface. But you can see here, the left-hand side is the auto. The scaling of this app is tailored to the tablets. That's why it looks a little big on my screen here. So I'm going to shrink it down a little. And I'll scroll down so you can see the whole thing. I'll try and scroll slowly because I know that these live displays can be a little jumpy. So up at the top, we're collecting the shooting into the ports. Auto on the left-hand side, tele up on the right-hand side, and a reminder of what the port looks like in the middle. And then down below, we try and track where robots are shooting from. And part of that is, in case they have a favorite spot they like to shoot from, and maybe part of the defense can be trying to knock them off that spot. That was in discussions with our strategy. That was with our strategy team. This was the information that they wanted to collect. And then down at the very bottom, you can see we collect the rotational control, positional control. Was this robot able to perform those duties? And then you'd click next, and we had some questions at the end of the game. How did the robot climb? Were they able to self-level? How did they play defense? How did they do against defense? Again, a strategy team came up with a bunch of questions on on what they wanted to learn from each match. You can put your name, you can put comments in, and then you can save answers. And the save answers would store the data on the server. And the nice thing about that is, I'm going to go back. Now, if you had all the tablets storing the data on the Raspberry Pi, you had all the data. And so then you could click on things like analysis here and get a table of all the data ranked by a calculated OPR. And again, this was the software just looking at the data that we stored, that we collected, and computing it against the scoring that was listed in that was given out in the game manual. This must be week 0. So let's go. Oh yeah, it's week 0. Let's go to the New Hampshire Granite State. Oops. We'll go here to the analysis. So this was one piece that we found really valuable with a scouting system like this, is by having the tablets feed all the data to the Raspberry Pi, you could write software that could then say, "Ooh, we've got all this data. Let's organize it, display it." Note that by default, it sorts the list based on OPR, but you can say, we want who's the best shooter of teleop in the inner port. And we could click on that, and then we can see that 5687, our scouters noticed that they did very well. Was able to shoot four shots into the inner port. So if you were looking for that kind of robot, the list was sorted based on how well they did there. So interesting way to gather information and assist with a pick list. And we even made it so you could follow along and select, well, they already got picked, so who's the next guy? And these guys already got picked, so who's the next guy? Who's the next best? So interesting having all that. But so the question becomes, how do we develop this? And that's what I want to talk about today, is how to develop a web interface like this that's interactive with the user and can collect data. So let's go back to the website. So the first part is developing your own web server. And this, I think, is really fun and useful for a number of things. Certainly the web-based scouting interface is good, but even just having your own kind of Raspberry Pi server in your home, you can create web pages, post pictures, and even create games, which is kind of what I'll show. A couple of techniques you can use to create simple games on the web, as well as a great place to practice if you're taking any JavaScript classes or interested in coding, learning stuff on the web. This is a place where you can have your own web server and develop your own codes. So it's very easy to set up a Raspberry Pi. First step is to install, get a Raspberry Pi. Once you have a Raspberry Pi, though, Ubuntu makes it very easy. I'll click to this page. The details are all in here. I'm not going to go into great detail, but so you can come, this is on the website, so you can come here anytime and look. But Ubuntu has a great page and a great little tool that makes it very easy to install and Ubuntu operating system, which is Linux based, um, on your Raspberry Pi. Um, and then they make it very easy, plug it in, connect it. So I have it physically connected to my router with an Ethernet cable. The Raspberry Pi is so small you can store it anywhere. So anywhere you've got an outlet and access to your router, you can plug it in, and then you can SSH or secure shell. It's a program that you can use. I noticed here, I logged here. There's a Putty.exe program that you can download, and I'll show you that real quick on my desktop here. Right here, it's a little Putty binary. So if I double click on it, this is one way I can log into my server. So 192.168.175. And I discuss how to create a static IP like this, but you can SSH into it, and I'm logging in as Ubuntu, and I'm given the Ubuntu password that I created, and I'm logged into the Raspberry Pi, which is in another room. So this is one way to do it, or I've got this other window open, which is Windows has been collaborating for years. Windows and Linux have been totally separate worlds in terms of operating systems, but recently Linux and Ubuntu have collaborated with Ubuntu to be able to have a Linux subsystem, I believe they call it. Let me go back to my web pages. I talk about it right here, the Windows subsystem for Linux. So if you have Windows, I don't know if they do it for Apple, but um, for Windows, if you have a Windows laptop, they have this capability called the subsystem for Linux. And that's where you can just basically pop up a terminal and you'll be running Linux on your Windows laptop. And then from here, I just typed SSH. Here, I can exit off the Raspberry Pi, up arrow, and that's what I typed to get into the Raspberry Pi, just SSH or secure shell. That's what that stands for. Ubuntu is the username I'm logging in, and I'm saying SSH into 192.168.175 as the user Ubuntu, and it prompts me for the password, same as the Putty the Putty program did. So these are two ways to be able to log into a Raspberry Pi. Like I said, once you have it somewhere set up, installed, and plugged into your home network. They also have directions for doing it wirelessly. If you don't have an Ethernet cable at home, you can set it up wirelessly. So the instructions are here, and like I said, it's very straightforward, very easy to follow. So once you do that, you log in the first time, you're going to be prompted. Ubuntu is the default password when you first log into the Raspberry Pi after you've installed it. It'll prompt you to change the password, and once that's done, you're just like I am here. You're logged in and you're ready to go. So the instructions are very easy up here at the Ubuntu website for installing on a Raspberry Pi. Okay, so now you've got a Raspberry Pi installed with Ubuntu. So the next page here is just a list of commands. If you've never used Linux, when you SSH in like that, you're in what's called a bash shell. That's the program that's providing you the connection. And so there's lots of commands available to you in there. I listed out a bunch of commands here so you can get familiar with using them. The ls command lists the contents of a directory. cd allows you to change your directory. When you first go in, you're in a home directory, so you can see where you are. pwd, you can see I'm in /home/ubuntu. So that's the file system within Linux. It's a very common file system. Slash and then a location and then slash to get into another directory. There's ways to copy files, move files to other directories or rename them, remove files, make new directories. Cat is a nice program. It's short for concatenate, but what it's intended to do is just print the contents of the file. It just dumps everything right to the screen. So if it's a big file, it will just scroll on. And so that's where a program like less is more interesting, because less will print the contents, but if it's more than the screen, it will stop. And you can use your arrow keys to scroll up and down and be able to, read the file and view it. So that's a nice way to view a file. And then, of course, to get out, once you're done, just type exit and it will log you out of that file. So just a quick quick page on some simple commands. Google is your friend. If you're new to software programming, uh, Google is your friend for learning anything about Linux environments. If you're looking for a command, try Googling what you're trying to do, and chances are you'll find the command, um, as well as learning software, um, which I'll cover a little bit later. So the next step is once you're in Ubuntu, if this is a fresh install, first thing I recommend is running app update and app upgrade. And that just app update goes out to the Ubuntu servers and says, hey, are there any new packages that I should install, particularly security packages, but any packages with patches, with bug fixes. So that will come back and say, yes, there are this many packages, and then you'll say, okay, let's install them, and that's what the upgrade does. And you have to run it with the sudo command in front because to do any kind of administration on any Linux system, you need to be the super user. Most times that means the root user, but in this case, since we're Ubuntu, we have super user privileges. And to invoke those privileges, any command we need to run that's an administrative command like app update, just preface it with sudo, meaning as super user, run this command. Um, if it's been a while since you've been at the shell or the first time logging in, you'll get prompted for your password just to make sure, are you really you, or did you walk away and somebody else is trying to do something to your system? But after that, it'll remember who you are as long as you're active in your session. So that's what these two commands do, and they'll prompt you. They'll say, "Oh, we've got a lot of software to install. Is this okay?" Just hit yes, um, and get that all installed. And now you'll be all up to date with all the latest security fixes and patches. Sometimes it might say you need to restart or reboot because it wants to install a new Linux kernel. So in that case, go ahead and follow the directions. But now you've got the latest. And then the next step is, now that you're in this terminal window, a great thing to be able to do is to be able to edit files. So we need a text editor. By default, VI is a very common um, program in Linux to edit files. So you type VI. Um, you'll want to Google it to find the commands to get out and how to use it. If you're familiar with it, you can use that. But for development work, I like a program called Emacs. It's another text editor that's been around for a long time. And it's nice for developers because it's got some extra features. It'll color code your code. It'll tab your code. Um, in software development, tabbing is a nice way to keep track of where you are in scope with your code, what chunk of code you're working within. So having a program, a text editor that will help remind you of where you are in scope, and color coding your code makes it really easy to develop and catch any typos and things like that. Those who develop with graphical tools like Eclipse and Edit, you can also do that as well. But I think it's handy to know how to edit text in a text editor, especially if you're going to get into the software engineering field or software development field. You often work on machines remotely, especially these days. Um, uh, you might be working from home, and so being able to work in a text editor is really handy. So for this presentation and in the following steps, I'm going to use the Emacs. So to install Emacs, it's sudo apt install Emacs. So if you type that at the login and follow the prompt to say yes, you'll get Emacs installed. And then I've got a quick tutorial on Emacs. Basically, I always run Emacs-NW. That just tells Emacs, don't try and start a separate window. We're not in a desktop. So it'll just create it in the screen. And then the name of the program that you want to edit. So I wanted to create a new file called hello.txt. So I type emacs-nw hello.txt. And if you do that, you'll see a screen much like you do here at the bottom. Um, You'll have a bar at the top with some menu items. Honestly, I've never tried clicking or tabbing over to those. And then you have a bottom bar down at the bottom. The two little asterisks means the file has been edited and it needs to be saved still. You've got the name of the file. It's also nice, you've got line numbers. The L2 down at the bottom tells you, my cursor is at line 2. So it's handy to know because errors in programming errors often tell you the line. Program scripting errors often tell you which line the error is on. And so it's nice. Emacs is nice because you can move your cursor until you get to the line where the error occurred. So another nice feature of Emacs. So once you type Emacs-nw hello.txt, let's just add a hello Dean. I added that, and then I wanted to save my changes and exit. And to do that in Emacs, you type Control X, which means I usually hold the Control button down with my pinky and press X, and then I type Control S, and that's for save. So Control X gets you down into this control bar at the very bottom, and then Control S is a way to say. So it takes you out of the Control X takes you out of the editing and down into the control bar, and then Control S means let's save. And then to get out, you say Control X, you type Control X followed by Control C, and Control C is a common it's a common way to get out of a program. If the program doesn't look for Control C, it's usually a way to interrupt a program, typing Control C. So you do that, and you'll come right out of Emacs back into the terminal prompt, and you will have created a file called Hello Dean. So you will have created your first file if you haven't played with that. I should have hit the next button. Okay, so now that you have your Raspberry Pi installed, you have a text editor installed. The next step is configuring a static IP address. You notice that I was able to log into 192.168.1.75. That is a static IP that I configured because my home router distributes IP addresses from 2. So 192.168.1.1 is my router IP address. If I need to get into my router, I point a browser to there and log in. And when I did, I looked in and noticed that it was serving IP addresses to all the other devices in our house. This is common, and I actually talk about it in the upcoming session. But this is a DHCP server. This happens at school, at home, anywhere you go, coffee shop. The router is a DHCP server, and what that's doing is giving out IP addresses to whoever needs it. So when you plugged in the Raspberry Pi, it was set up to request an IP address from a DHCP server. And so that's great. And you figure out what the challenge is figuring out what that IP address is. And you can log into your router and it'll show up that way. Or you can hook up a display to the Raspberry Pi and a keyboard and query that way. But the challenge is staying with DHCP. It's going to move around. If you have a power outage, if you reboot, and while it's rebooting, somebody comes to visit your house, their phone gets on your Wi-Fi, it might take the IP address that was given to your Raspberry Pi, and now it has a different IP address. This is kind of common if you have a printer in your house. You set up your laptop to see the printer, and then you have a power outage, and you set up, and then suddenly the printer stops working, and you're like, why? Well, it's because when you set up the printer originally, your laptop stored that first IP address it got, but then during the power outage and then back up. So when it came back up, your router gave your printer a different IP address, and now your laptop can't find it. So configuring static IP addresses for things you need to connect to, like your printer, or in this case, a web server, it's good to configure a static IP address. And so this step here covers how to do that. You have to edit a file, edit this file with Emacs, and change. So when you get into the file, you'll see DHCP4 here. You'll see it set to true. And what we're going to do is set it to false, saying, no, we don't need to make a DHCP request. We're going to configure a static IP. And so in this case, I picked 75. And the /24 is part of the NetMask. You can Google to learn more about NetMask, but basically that helps. That the NetMask controls how big your local area network is. So even though my router serves from .2 to .50, the NetMask says that it could serve from the whole subnet in my house. If it's 24, that means that the whole subnet of my house goes from 1 to 255. It's a whole. You can Google on the web to find more details on that, but that's what the NetMask says. A NetMask looks like it's either 24, or you see it in an IP address form as 255.255.255.0. And that's equivalent to 24 because each 255 represents 8 bits. If you know binary, there's 8 bits to create the number 255. And so 3 255s adds up to 24. So that's how the syntax 24 comes about for a NetMask. But so this is just telling this server that your IP address is 192.168.1.75, and your range of other IP addresses that you can talk to is only 192.168.1.1 to 192.168.1.255. So a little long-winded on that, but that's what that means. The gateway is configured as my router. That means if you need to get out of this network that's defined by the NetMask, if you need to go to Google or any other website, Apple, those you're going to have to go out through the router, and the router is the gateway. And then finally, the name servers is, well, if you need to find out what the IP address is for google.com, this is the address that you need to go talk to. And he is your name server or DNS server. He's the one that's handing out it, he's the one that maps names to IP addresses. So when they created the internet and created computers, you have host names and you have IP addresses, and the host names are just so to make it easy for us to, as humans, to remember a location. It's easier for me to say google.com than to say whatever the Google IP address is, which could change. So that's what the name server is. And I got this name server from my router, and the name server is going to be whoever your internet service provider is. They provide the IP address. So I'm in Brookline, New Hampshire, so my internet service provider provided that IP address to my router, and so when I went in and looked at my router, I was able to get that. So I made these changes in red in this file, and then I save and exit, and then the comments up here say this file is automatically created on boot up. So if you want to turn off that, I don't want my changes to be overwritten. So it says if you want to turn that off, create this file and put the following in it, say network config disabled. So I had to do that as well. So I ran, and again, you have to run sudo Emacs because you're editing, you're performing administrative tasks. So to edit this file up here, I had to run sudo Emacs to be able to make those network changes. And down here, I have to run sudo Emacs as well. And I added the network config disabled just as it's explained. Okay, we've almost got our Raspberry Pi server, and I should speed up a little bit. So let's see what's next. Okay, so the next part is installing a web server. So this is where we're going to install Apache 2. So sudo apt install will install Apache 2. So Apache 2 is a very common web server. I added a link that'll tell you that Apache, it does web analysis, and it says Apache is used on 1/3 of all known websites on the internet. So a very common web server. It runs apple.com, it runs craigslist.com. So a lot of companies use Apache, and you're now going to have it running in your home or at your team site. How does it work? All a web server does is it's configured to look in a location in a directory for a file. By default, if you just specify google.com, then the file that that the web server at Google is going to find is called index.html, and Apache provides that. So on your Raspberry Pi, the document root is /var/www/html. So this is where Apache will look for files, and it puts in this default file when you install it, and this default file presents the page that you see here in the picture. So that's all a web server does. Whenever you access it and you pass on different file names, all it's doing is looking in this directory, finding that file, and giving it to you. Well, that's not going to work for our interactive pages. We need more from our web server. And so in this case, what we're going to do is we're going to take advantage of a technology called Common Gateway Interface, or CGI. So what this does is when you enable a web server to support CGI, it means instead of looking for a file to just return, to give to your browser, to the browser that asked for it, it's going to run a program. And a CGI script is a program that can accept input, and we'll cover that, and it will print out a web page. So that's how we're going to create our web pages, is we're going to write scripts that print out web pages, and they also take input, and they can also, read input from files like scouting data storage files. And so depending on what the user passes into that script, the CGI script, will decide to print different web pages. And you can see that here in the scouting app. So up here at the top, you can see I'm in CGI bin index.cgi. So I'm a CGI script actually created this web page. It's not a .html web page. It's not a static page. It's a dynamic page. And that's because what it does is it looks in the directory for match data, and if it finds match data, it lists the match data and creates these pages. So it creates the link for the scouters. So if we go to another event and you have to upload match data for that event, then if we go to, let's say, district champions, then we would need to upload the match schedule for district champions, and that would show up in here, and your scouters could click on it and then select a match and scout it. And then once they start storing data, then this CSV file will show up, which is the scouting data in raw format. And you'll also get links like the analysis and the prediction links. So this page, if I click on the event, you'll notice up here that it changed. There's a question mark after the index.cgi, and now there's input being provided to this CGI script, and that input is event equals New Hampshire Granite Regional, the Granite State event that happens in Salem, New Hampshire. So what this script did is it didn't list all the matches available. Instead, it printed a different page. It printed this page that says, all right, if I'm given an event, I'm going to find out, all right, whoever's looking at this page, you need to tell me who you are. Are you red 1? Are you red 2? Are you red 3? And what's your orientation, so that I can present the field the way you're looking at it, right? Is the red alliance on the left, or is the red alliance on the right? And that was all. So this web page changed. It's the same web page, index.cgi, but because we gave it different input, it printed a different page. So that's the value of CGI script and the Common Gateway Interface. So we need to enable our web server. The Apache web server doesn't enable CGI by default, and that's because CGI means you're now running programs. So all your users that access your web pages are generating activity on your web server beyond just retrieving a file. And so you want to be careful with that. You don't want to overload your, in this case, we've got a Raspberry Pi. We wouldn't want 100 people trying to run programs and generate a lot of activity on a Raspberry Pi. We would want a bigger server if we knew we were going to have more users than that. So we need to configure CGI in Apache 2. 6 users on the Raspberry Pi is fine, but 100 might be too much. And so by default, web servers don't want to enable CGI to finish that. So to enable CGI in Apache, you run this command, which will add the plugin. So sudo and then the A2N mod is short for Apache 2 enable a module, and the module is CGI daemon. So this will launch us a daemon that will be in charge of executing CGI code. And so it says, okay, activation worked, but before this feature is enabled or activated, so the module is enabled, but before it's activated, you need to restart Apache 2. Before we do that, I suggest one more change. So if you look in the configuration for CGI support, it's going to look in userlib CGI bin by default for all of its CGI scripts. And I didn't, so it's right here. So we're looking at this file. I use the cat command to list out this file, and you can see it's configured by default to look in userlib CGI bin. Well, I don't want to keep code in 2 separate places. Var www var www/var/www/html is the document root. That's where our static web pages will go. But we want to configure our CGI scripts right next to that. I want to keep them close. So I changed this location to /var/www/CGI bin. So I edit the file. I use sudo emacs -nw, this file, and I change the user lib to var www. And then I save and exit, and now I can restart Apache 2. So here's the sudo restart Apache 2. All right, and I'm running a little bit long. We're not going to get to too much here. But I can, in fact, let me go to the scouting home. So that's it. We've restarted our Apache server and we have CGI support enabled. So we've covered the first section here. And now the second section is down here. We're going to focus on developing interactive web pages. So the first thing, I don't know how many of you have been able to play with HTML, but it's pretty simple. So the first test is just to serve any old file. So remember that hello.txt file? Just copy it. And we have to use sudo because the location var www.html is owned by a super user. So we need to be super user to copy any files into that location. So I copied that file into there, and now I can see there's the original index.html, and I see my hello.txt. And if I add /hello.txt to my browser up here, well, one of these, I'll go back. But if I add /hello.txt to the IP address of my Raspberry Pi, I see the hello Dean. So the next step is let's turn that into a web page. So web pages are created with hypertext markup language, which is HTML. And it's basically these tags saying, here's the start of HTML and here's the end of HTML. Here's the start of head. Here's the end of head. Here's the start of the body and here's the end of the body. That's the basic structure of an HTML page. So if we edit our hello.txt, we actually create hello.html. We'll use the extensions at the end to describe the type of file it is. So .html says this is an HTML file. We put that structure and we create a little title that says greetings. Otherwise, we put the hello Dean in there, save and exit, copy this file so I created this file locally in my Ubuntu directory. And then I copy it using the sudo, and then I add /hello.html to my Raspberry Pi IP address in the browser, and now I see those contents. And I will see hello Dean, and I will see this greetings up here at the top. This is where titles go. So you can see simple HTML FRC 1073 up in the top tab for this browser. That's the title. So that's simple HTML. The next step, so there's more HTML. So this just goes into more examples onto the tags. So we add a H1, that's a header tag in HTML, and we put the end of H1 here. And that's going to make Hello Dean present bigger. It's going to look, if you look at this page, the more HTML examples is in bigger print than the paragraph. That's what the header tags do. They increase the size of the text. The next test 4, is to play with even more tags to get you familiar with HTML. And if you're new to HTML, I recommend finding a good website that explains the various tags. And so I listed one down here. It's HTML Gelfreezy HTML. It's the website is HTML by example. So if you need more explanation on, if you're like, how can I create a table, or how can I change the color? All that information you can find in websites like this. Again, Google is your friend with coding. So, but that's basic HTML, and it's good to know how to present, how to print, how to create HTML, because we're going to write CGI scripts that know how to print HTML, that are going to be coded to print HTML. So here's an example here. I use Perl scripting, but if you're familiar with Python or any other code, you could do it with Java. That's a little bit heavy-handed because you've got to compile Java and run it. I don't know if I would use Java, but if you're familiar with any scripting language, I'm going to use Perl. Python is another obvious one. All you need to do is print. So this is going to just print Hello Dean, and this is just an introduction to Perl. So when you write a script, up at the top, the first line with the hash and then the bang is a way to tell the interpreter, the bash program, what language interpreter you need in order to read the rest of this file. So this says, at the very top, it says this needs a Perl interpreter to be able to read this code. So that's the first line. The next 2 lines describe turn on debugging, be very strict, make sure, yell, print any warnings or errors if you see anything wrong with my code. And then this Perl script is just going to print Hello Dean, and that's how you do it. It's very simple. We want to make a CGI script. So we're going to add more print statements. The first line needs to be printed for all CGI scripts. So if you're running this in Python, you need to print this line, or using some other language, you need to print this line. And that's because when that first print statement is executed and is parsed by your browser, because that got sent back from the server, it knows, I've got HTML coming in. And then the rest of it is the HTML. So here's the beginning of HTML, the head, the title, the head, the body, and you can see I changed the background color of the body. So I made it red. Otherwise, I centered the content, and the content is going to be Hello Dean. And then I close the body, I close HTML. I print that. I can just run it, and I print. And running a CGI script is always an excellent way to make sure it looks the way you want. You didn't forget a slash or anything like that. So you can run it on the terminal and make sure that the output looks like HTML, and then you can install it. So we need to copy it. So if this is the first CGI script, you probably need to create this directory. We configured it, but now you need to create it. And I'm going to run out of time here, I can see. But you need to create the location, again with sudo, copy it, and you have to set permissions to make sure anybody can execute it, because the web browser, the web server needs to be able to execute it. Once you do that, the last step is how do you provide input to CGI scripts? So now that we have that, and we've already discussed that, it was the query string, it was the question mark. We saw that right here, the event, the question mark and the event. This is how you provide input to CGI scripts. So this example writes a program, and it teaches you a little more about Perl, but it's basically going to look at its environment. So every program gets arguments and environments information. And so we're going to write a program that parses its environment information and just prints it all out. And so when you run this, and I think I have this here, let me run it real quick. So here are all the environment variables of my CGI script. And it's interesting, you see the remote address. So my web server is displaying to my CGI script that who the client is, who the browser is, the IP address of the browser that's making the request. But what we want to pay attention to is this query string right here. Because if I go up here and add the question mark, and I say 1073 equals force, and I hit enter, now I look at that query string, and here it is. So this is how we pass input to the CGI script. So the CGI script parse the environment variables, and in there is a query string that will contain whatever is after the question mark in your URL string. And this is how the scouting apps take input. So if I click here, now you can see I picked red 1. So up here it says, well, at this event, we are position 1 and we are oriented with red alliance to the left. And so now the CGI script, okay, I know who, I have my scouter. Now let's list the matches that this scouter could scout. And he clicks on that. And now it says up here that this, you can see the game is now which match it is, as well as the event and the team that's being scouted. And if I click up here, you can see again, more arguments are getting passed up in the URL. And so the Perl script, and that's what gets covered in here. I'm running out of time, so I'm skimming kind of quick here. But that's what the rest of the steps down here do, is show you how to write Perl scripts to parse that query string, break it up. It uses some Perl commands called split that allows you to split a string into various pieces. And then you can create, and then you can parse that input and decide how you want to print different HTML based on the input. And the last example here, I'll show you, we write a counter program that just counts, counter.cgi, it just counts a number. So without any arguments, you get 0. If I hover over increment, if you look down in the left, I don't know if you can see it, but whenever you hover over a website link down in the lower left, sometimes your browser will show you the link that you're about to click on. I'll click on it and you can see it up in the URL. It's question mark count equals 1. So now that count equals 1, the 0 is now displayed as a 1. And if I hover over increment again, I see count will be 2 if I click on this. And so what this code will do here is show you how to write Perl to do what that is. And so good programming practice is to think about the steps that you want your program to do. So number starts at 0. If we're given a number, we're going to set the number. If we're given a number, we're going to change from 0 to whatever we were given. We got to print the number, and then we're going to make 2 links, one above and one below, where we take the current number and we either add 1 or subtract 1. And then I show the Perl code and describe the Perl code that does that. So here's the code that parses the query string. So it says there's a command in Perl called exists. So if exists this query string in this environment hash, then get it. So set this variable to that value, and then split that value on the ampersands, because when we saw up here, you see all these ampersands dividing these settings. So game equals this game, and team equals this team, and auto equals these settings. So that's what this code is doing here. It's splitting on the settings, and now for each setting, we're doing a for each loop. For each setting, split the setting into its items, and it should only be 2 items. If it's not, then something got wrong. something got passed in wrong, and we'll just skip it and move on. Otherwise, if the argument passed in is the count, then we set our count, which was originally 0, to the new value. So that's how it's parsing the query string. And then the last bit is just printing, calculating the increment and the decrement values, and then printing web links. Um, and you can see it prints the count in the middle. So a little rushed at the end. Sorry, my first time presenting. But this, again, all the details are here in this web page. Please feel free, take your time, read through it. And I hope I've put enough information in there to help you really get started and have fun with your web server. And there's also information, there's another example on creating a tic-tac-toe board. Like I said, you can create anything you want. That's the beauty of software development, is to create anything you want. Um, any kind of applications, post pictures, like I said. But in this case, you have the tools to begin developing a scouting app. And there's also instructions here on where you can download the code that we wrote for our scouting app. So you now know how to read it and can understand how it works, and hopefully make it better. Create the scouting app for future games. That's really my hope in making this information available, is that anybody interested can create and develop their own scouting apps. That's the end of my presentation. I hope everybody's. I hope this went well and everybody heard me. I'm going to check on the questions. Here we go. So, is there a machine learning component? I didn't develop that, but you could. That's the beauty of software. You could add any kind of aspect. Now that you have the data and you have a code, you can get as creative as you want. I know in talking with our strategy team, there's all sorts of calculations we wanted to add to try and analyze, what would be the best robot to pick. One feature that we found really cool, and I hadn't thought of this, one of the kids came up with this, was the match predictor. So once you have a day's worth of data, um, you can use that. Well, let me go back here. You have a day's worth of data, you go to the analysis, you've got an average OPR now. You can calculate, for that day, this team, 95, was creating an average OPR of 78. The Grasshoppers are a great team. I like watching them. So they had a very good OPR. So once you have a day's worth of data like that and have a sense for what robots are going to do, now you can create matches. And we thought this was really cool because you can now. Well, let me pick the predictor for the granted state. We got more teams. Now, if you pick 6 teams, put them together, what you can do is you can list out their OPRs and add them up. Now, so you can say if these 6 teams played each other, what would the score look like based on what we have for information thus far? And you can try and start predicting scores. And so this can be fun at events. It can be useful because on your last day, you can say, hey, we got a match coming up. We're playing with these guys against these guys. Plug them into the predictor and what does it say? Who's going to be the strongest guy? How are we going to do? And you can also do this at elims as well, because by then you'll have a whole lot of data. And as the matches go and as you collect more data, it can get more and more accurate as to how well the robot can do. Everybody has a tough match every now and then, but you want to try and get a good number, and then you can begin playing with it. So it's not machine learning, but it's kind of cool things that you can do. Is there advantage to use a Raspberry Pi versus laptop? Uh, the only advantage I can think of is power. If you got a good laptop battery, can last all day, or you can swap out that robot battery, that would be fine. You can use a laptop. The Raspberry Pi will last all day on a robot battery. We found that, so that's great. And it's portable. You just tuck it under a seat at an event, and nobody's gonna hit it or anything like that. But otherwise, the laptop might respond better because, as I mentioned, you've got the Now the Raspberry Pi, we've got 6 tablets clicking, and every time you click, you're running a program on the Raspberry Pi to regenerate a new screen. And we've actually seen that with 6 tablets. It can get a little slow on a tablet or two. A user might have to click more than once to get it to respond. So a laptop in this case would probably be faster, right? It's going to have a faster processor. Uh, i- if you run into lag like that, a laptop could be a better solution. C or Python. You can use any programming. Your CGI script can be any program it needs to be. You could write it in C and compile it. If you're strong in C, C is I love C. That's actually why I chose Python because, or sorry, Perl, because I feel like you can code Perl. I can write Perl the way I write to C, with the if statements and the for loops and stuff. So I like C, and so that's why Perl is my favorite scripting language. Um, but Python has been very popular. I know they're teaching it in schools. So if that's what you're familiar with, you can write. I was actually going to try and write some of the examples. I had a thought to try and write some of the examples in Python as well, just to help people who are stronger in Python than in C. Um, so that looks like it. Thank you for watching today. I hope this was interesting to you. I hope you guys enjoy it. Um, can have some fun with it. Um, I'll go ahead and give out my email address. I'm chris.holmes@frc1073.org. If you have any questions, I hope I've got everything on the website. But if you want to ask me any questions, feel free to send me an email. Thanks, and take care. Thanks for watching.